Hi everyone, welcome back to another Data Teach lesson where I'll be going over subsetting and indexing data in pandas as part of our data manipulation series. So first going over how we can subset and index data with columns. In order to access a column from a data frame we can use its name as an index. So for example, here we have the iris data set and we want to access the sepal length column. And in this case, the syntax would be a bracket and then the name of the column, sepal length, in quotation marks. In order to access multiple columns, we would want double brackets instead, and the names of our columns, sepal length and sepal width, within their own quotation marks, separated by a comma. So again, this is the syntax if we want to get a single column, and this is the syntax if we want to obtain multiple columns. Now, what if we wanted to subset and index data with both rows and columns? So in this case, we would use .iloc, which is integer location based on numeric indices. So the first line here, we can see the general syntax of how to use this .iloc. So it would be the name of your data frame, .iloc bracket, and the first value will be your row selection, comma, and then the second value behind the comma will be your column selection. So, and if there's no comma, you can just assume that you're only talking about the row selection. So here we have our first example, df.iloc bracket 0. And in this case, it will select the first row because it is the first value. And again, with Python, remember that Python uses zero-based indexing, so 0 is actually the first row. Moving on to the next example, we have df.iloc and a semicolon, comma 1. And whenever we see semicolons, we can assume that we are getting all the information of whether it be the row or column, depending on where it is in regards to the placement. So here we can see that the semicolon is before the comma, which is our row selection. So we're selecting all rows, and then 1, which means the second column. Again, Python uses zero-based indexing, so it's kind of counterintuitive. We would think that we're selecting the first column, but it's 0 and then 1, which means we're selecting the second column. So here we are selecting all rows from the second column. Next, we have df.iloc bracket 0 semicolon 3. So in this case, this is an example of slicing, and basically we're selecting rows with indices 0, 1, 2. So you can just assume that 0 is included and we're selecting up to 3 numbers. So 0, 1, and 2 is all the rows that we're going to be selecting, and 3 here is excluded. And again, since this is before the comma, it will be all the rows with this value. Now for number 4, we're combining all of the things we saw in our last example. We have df.iloc bracket 1 semicolon 4 comma 0 semicolon 2. So first we are going to look at the values before the comma. So before the comma will be row selection again. So we have 1 to 4. So we know that 1 is included and 4 is not. So we know we're selecting rows 1, 2, and 3. And then after the comma, we have 0 semicolon 2, which means that once again, 0 is included and 2 is excluded, so we'll be selecting columns 0, 1. So we're selecting rows 1, 2, and 3, and columns 0 and 1. And there's another way to do location where we can do .loc instead of I.loc. And here we can just, it is the named indices. So we can just select the sepal length and sepal width instead of using the indices of the columns. And lastly, we also have another .iloc, and this is integer indices. So once again, this is named and this is integer. So .loc is corresponded with names, and then .iloc is indexed. Just remember the I is equal to index. Okay, going more into depth with .iloc and .loc, the key point is indexing with .iloc is zero-based, while .loc it accepts integers, slices, and a list of integers as we saw from the previous slide. And also out of bounds indices will raise an error. So for example, if there's only 5 columns, but you put 7, you're trying to index 7 columns, then it will raise an error. So comparing .iloc and .loc, the selection for .iloc is by integer and position / index, while .loc is by the label or index name. And type of indexing is integer-based, .loc is label-based. This raises an index error for out-of-bounds indices, and .loc raises a key error for missing labels. Boolean masking, which we'll dive into in later lessons, requires integer positions, and .loc supports Boolean masks directly. And finally, for performance, .iloc is slightly faster because it's index only, and .loc might be slightly slower because it might involve some additional label checks. So next, we'll be going over subsetting and indexing data using conditionals. So the purpose of this is to focus on a specific subset of data for analysis. And using this, we can filter out irrelevant data and explore the data we are only interested in. And for here, we can see we're using the .loc property to apply conditions and subset the data. So again, .loc is label-based indexing, where we can directly call the label or name of a column. So here we're doing the iris petal is less than 1.5. And what this does is create a property that only with petal length under 1.5 the data will be selected. Otherwise, it'll be excluded. And for subsetting conditionals, you can use different logical operators. There is the AND, which is the logical AND, this is the logical OR, and this is the logical NOT. Next, we'll be going over grouping and aggregation. So grouping involves splitting the data into groups based on certain criteria, which is usually a categorical variable. It allows you to analyze or summarize each group independently. And after you group data, you can use aggregation functions such as mean, sum, min, max, count, etc. to evaluate meaningful statistics for each group. Aggregation reduces the group data into a single value for each group, which can be seen in this example. Now, you don't need to necessarily know what all of this code means, but just see that we're grouping by species and separating, or where we want each species petal length and then the mean of each group's petal length. So here we have the different species, Setosa, versicolor, and virginica, and we can see the average petal length for each of the species. That is all for our lesson about subsetting and indexing, and please watch our next video about grouping and aggregating categorical data. Thank you so much for watching.